Hey guys, today we're going to talk about dividing fractions. Some definitions first. The reciprocal is the multiplicative inverse of a number. For example, if I give you the fraction 2/5, the reciprocal of that would be the inverse. So that number flipped over. And so the inverse of 2/5 is 5/2. The reciprocal of 2/5 is 5/2. Same thing if I have the number 1/3. The reciprocal of that is just that fraction flipped over, 3/1. The quotient is the result when two or more numbers are divided, but today we're actually going to turn all of our quotients into products. So the product is the result when two or more numbers are multiplied. Vic, number 1, very important concept, number 1. Rewrite each division of fractions problem into a multiplication problem by changing the second fraction into its reciprocal. I'll show you some examples. Number 1 here, we've got 4 divided by 2/5. Remember in the previous video, I told you anytime you have a whole number, you need to rewrite it as a fraction with a denominator of 1. So I went ahead and did that here. Then we're going to change the second fraction, which was 2/5, into its reciprocal, 5/2. When we do that, it becomes a multiplication problem. So 4/1 times 5/2. When we multiply fractions, remember we multiply the numerators. 4 times 5 is 20. Multiply the denominators. 1 times 2 is 2. Then we reduce. 20 divided by 2 is 10. Example number 2, I'll do here with you. We have 10 divided by 2/3. Remember, anytime we have a whole number, we're going to rewrite it so that it has a denominator of 1. I'm going to change my division to multiplication, and then I'm going to multiply by the reciprocal. So I'm flipping over 2/3, and I'm rewriting it as 3/2. Remember, I multiply the numerators. 10 times 3 is 30. 2 times 1 is 2. 30 divided by 2 is 15. 15 is my final answer. Some more examples. Now I've got two fractions that are already written as fractions, so I'm not dealing with whole numbers now. I still keep this first fraction the same, and then I change division to multiplication, and I'm going to multiply by the reciprocal of the second fraction only. So I only flip the second fraction. So my problem, 1/5 divided by 2/3, changes to 1/5 times 3/2. When I multiply fractions, I multiply the numerators. 1 times 3 is 3. 5 times 2 is 10. I cannot reduce that any further. For number 2, we've got 2/5 divided by 7/10. So I keep 2/5 the same, I change division to multiplication, and then I flip over my second fraction. So 7/10 becomes 10/7. When I multiply fractions, I multiply the numerators. 2 times 10 is 20. 5 times 7 is 35. And I can reduce this. 20 divided by 5 is 4. 35 divided by 5 is 7. My final answer is 4/7. Here in example 3. Remember, I keep the first fraction the same. So that's going to be 4/5. Change division to multiplication, and then I flip the second fraction over. So even though 1/2, when I flip it over, becomes 2, I still need to write that denominator 2/1 so that I can multiply correctly. 4 times 2 is 8. 5 times 1 is 5. When I reduce, I have 1 and 3/5 left over. Some more problems. These are starting to get more challenging because now I've thrown in some mixed numbers here. So before we change any of our problem, we first need to change our mixed numbers to improper fractions, which is what I did here. 1 and 3/5 needs to be changed to an improper fraction To do that, I multiply 5 times 1, which is 5. 5 plus 3 is 8, 8/5. And then I just continue with the rest of my problem. And now from this part, I'm going to change it. So this is where a lot of students get confused because they choose not to write all of their steps down. We need to rewrite the problem after I've changed it to an improper fraction so that I don't get confused. If I went straight from this step to this step, I might flip the wrong fraction, which will not give me the correct answer. So please make sure you're writing all the steps down. Once we have this division problem, I'm going to change it to a multiplication problem. 8/5 times 5/9. I multiply my numerators to get 72. I multiply my denominators to get 25. And then I reduce. 2 and 22 25ths. For number 2, same thing. I've got to change my mixed number to an improper fraction. Once I've written down the whole problem, then I'm allowed to change it to a multiplication problem. So here I've got 20/3 times 7/4. If you remember from the previous problem, I talked about cross-reducing. Cross-reducing helps so that you're not multiplying big numbers together because you're going to have to simplify at the end anyways. So cross-reducing helps you a lot. I'm going to divide both of these numbers by 4. 4 divided by 4 is 1, so I cross it out and put a 1. 20 divided by 4 is 5. Now I multiply 5 times 7 to get 35, 3 times 1 to get 3. I'm left with 11 and 2/3. In these examples, I've got 2 mixed numbers, so I have almost double the work. I've got to change both sets of mixed numbers to improper fractions. Once we've changed them to improper fractions, I change the division problem to a multiplication problem. So 19/2 divided by 11/4 becomes 19/2 times 4/11. Again, I'm going to cross-reduce so that I don't have to multiply really big numbers together. So 2 goes into 2 one time, 2 goes into 4 twice. 19 times 2 is 38, 1 times 11 is 11, and then I just simplify my improper fraction back into a mixed number. So I get 3 and 5/11 as my final answer. Problem number 2, we work essentially the same way. We change our mixed numbers to improper fractions. We change our division problem to a multiplication problem. Cross-reduce, multiply numerators, multiply denominators, and then change my improper fraction to a mixed number and make sure it's in simplest form. Please try these 4 problems for homework tonight and then bring them to class tomorrow and we'll go over them.